Okay, let's take a look at our electric project. I want to make sure that everyone has the same circuit in front of them at this point. So your circuit should have, your board should have three lights. One, two, three. The lights indicate one, that it's the compressor and the compressor fan motor, and two, that it's the indoor fan motor at the air handler, what circulates the air through the house. And the third one is the heat, the house heat. In this case, we're going to say it's electric heat. Your board should have one, two, three relays or contactors. And remember, the relays are really kind of what the most difficult piece is, because one part of the relays here in this high voltage side, the stuff that's above the step down transformer here, and the stuff that's below the transformer is the low voltage side. So part of the relay coil is here, and part of the relay coil here is up here. And this relay coil is physically here, and that makes it difficult. You should have a line switch, which I'm pretty sure all of you do. The line switch, remember, has one connected to the switch is just the L1, that black wire. It should be 16 AWG. Remember, AWG stands for American Wire Gauge. If it's a thicker wire than 16 gauge, then you're working against yourself because it's harder to use. That's what's going on with this L1. Over here, the neutral return should be a white wire, and that would be 16 AWG as well. So we come here, and our hot wire, when we close the switch, is we have power that's waiting for this relay to close, power waiting for this relay to close, power waiting for this relay to close. When we close the L1, the only thing in this circuit that's operating right now is the step-down transformer has power. And so the power flow goes like this in this ladder diagram and up to the neutral return. Now, what's happening in the 24 volts? Remember, in HVAC, we use 24 volts AC to control high voltage. Usually it's 220 volts, in some cases 440 volts, but definitely 220 volts for residential work. These 24 volt wires are very small. They are thermostat wire. And instead of being 16 gauge AWG, they are 18 gauge AWG. And all the wires that's now on your low voltage piece of your board should be this 18 gauge wire, and the Y wire should be yellow, and the G wire should be green, and the W wire should be white, just to keep track of everything. The R and the blue. The R is your red wire. It's what we use in low voltage is your hot wire. And your blue is your return wire. So you see on the other side of the coil, all of these guys get connected to that blue wire, and it comes back around and goes right to that return on that step-down transformer. And all of our wires coming from the hot wire of the transformer is here. You have power waiting to go through this coil, and power waiting to go through this G coil, and power waiting for you to close that W switch so it can go through that. So it works just like this. This is going to work like that. The only difference is this is low voltage and the other is high voltage. Remember, your high voltage is 120 volts AC, 60 hertz. And this symbol over here is that green wire, that ground wire. So at this point, everyone's board, all the team's board should be looking like this.